Hey guys, how you doing? Again, this is question 6. This is one of the ones from way back when. So this is actually a reminder from the first test. So this is the acid-base definitions, lecture 2. This is slide 8. And we're looking for the conjugate acid or base of the following materials. So anything, if it could be an acid or a base, then I can take either. It's no big deal. So CH3COOH does not have the ability to pick up a proton, so it can't act as a base. It has to act as an acid. When it acts as an acid, it has to donate H+. When it donates the H+, it becomes CH3COO-. Okay, so that's the one that we're talking about with that. So that guy right there. Okay, when we talk about the next one, COOH minus, there is no way that COOH minus can lose another proton. If it did so, we would have COO, but it'd be 2 minus, and that's not a known species. So that's not something we typically see. With it being negative like this, I would expect that we could add a proton to it. And of course we can, and that makes HCOOH. So this species right here. When we look at NH3, NH3 is a weak base. It's listed in the weak base that's on your exam handouts. If it's going to act as a base, it picks up a proton. Oh, and COOH minus was a base as well. When it picks up that proton, it becomes an NH4+. So this species right here. HSO4 minus can act as both an acid and a base. So when it acts as an acid, it's going to donate one more H+, and that becomes SO4 2 minus. Okay. I know this because it's in the list of polyprotic acids that's on the exam handout. So that's a place I can check for that. And that was actually how I saw that this particular species, the COOH minus, couldn't act as an acid again, because I wasn't sure if it could or not. I was like, okay, it has another proton that we might be able to get rid of it. Can we do that? But it's not on that list, so it can't. But I also know that HSO4 minus can pick up a proton, act as a base, and then it becomes H2SO4. So that guy right there. And so it can act in either way, and therefore we can take either one of these answers. Doesn't matter which. H3PO4 is an acid. It's a triprotic acid. When its base pair, however, is only the loss of one proton. So that's H2PO4 minus. So this guy right here. Hopefully that will take care of number 6. I'm going to go ahead and stop sharing. And I'm going to stop the recording, and I'll see you soon.